Welcome, everyone. We're going to go ahead and get started. We are so glad that you could join us today and have this important conversation around blockchain. I'd like to kick us off by turning it over to Pete Saronis, founder and chief executive officer of Dotson Bridges and the former chief technology officer at the U.S. Department of Energy. With that, take it away, Pete.
Thank you, Nika. I'm beyond honored and excited today with our esteemed panelists, guests, thought leaders. We're going to just contextually talk about a number of things that will be hopefully educational, informational, and enlightening. We promise not to delve into too much detail on what's blockchain and why and go down that black hole. We may reference it a few times. We may mention the words digital currency, cryptocurrency, but again, this is to talk about our future state grid, our critical infrastructure, and you're going to hear from the best and brightest with this eclectic and amazing group of people. So you heard a little bit about me, fireside chat. We are hopeful that you will follow up with everyone individually to learn more. So with that intro, I'd like to introduce our guests, and I will be looking down on occasion just because I can memorize some stuff, but not too many things. Mr. David Benton, Manager of Partnership Development for Cybersecurity, among many other items here at the Department of Energy through the National Renewable Energy Laboratory. Mr. Tony Markle, the Senior Researcher for Partnership Development, Secure Cyber Energy Systems Group at the National Renewable Energy Laboratory. Anthony James, Senior Engineer and Data Scientist at Southern California Edison, SoCal Edison as it's also referred to. And Mr. Chris Irwin, Program Manager for Transactive Energy, Communications, and Interoperability in Smart Grid at the United States Department of Energy, a friend, a colleague, and someone I respect immensely. So that's who we have today. What I'd like to do is maybe, David, let's kick it over to you to kind of contextualize a bit as to why this topic is so important to one of our nation's most incredible national treasures in the laboratory itself out in Colorado.
Sure. Thanks, Pete. So when we were brainstorming different ideas on, what can we put a webinar on about and what's going to really resonate with the energy community, through all the different topics, blockchain just rose to the top. I'm coming from 20 years in the utility space, working strictly on cybersecurity. And I thought back to some of my times at the utility where, blockchain is coming. What is this going to mean to us? What's it going to impact in the energy environment? And what problems is it really going to solve? Why are we even considering blockchain? So I think we've put together a really good panel of experts here and really have an exciting and informative session planned. So really looking forward to the conversation.
Yeah, and I want to offer folks the humility that you will feel throughout from these individuals. There's something that's consistent if you reach out or look at their pedigrees on whatever publicly available website you choose, but it's like over 20 years, over 20 years, over 20 years experience. So again, these folks know what they're talking about. And it, again, is not one thing. They understand horizontally how all of this ties together in light of what we're doing in our country in terms of building a more resilient power grid among other sectors. And I will say we've got three great mechanical, electrical, engineering types in our next guests. So while David has industrial technology and an MS and IS, we got some smart dudes literally on this call. So thank you, David, for that. Let's go over to Chris Irwin here. And Chris, why don't a little bit of background and a little bit of your passion for this very topic?
On the blockchain front is that, yes, I've been around the block on smart grid. I was around for the Recovery Act investments, and I got to join the Department of Energy, and then they handed me $1.6 billion in projects, and they said, do a good job. So it was sort of a crash course in really the full diversity of smart grid technologies and options that are out there. But just like Dave said, is that, as a blockchain is a very compelling technology, not really for the currency implications, but for its other capabilities. And so, I've obviously had an opportunity to invest through some SBIR projects and some lab projects on exploring blockchain technologies. But I think that the most important thing to acknowledge, even at the government R&D and the jewels of the crown that we have here, is that we are not going to be the only ones who come up with the great ideas. And so we needed ways to experiment with where blockchain fits into energy sector use cases, but also we needed to pave the way to let other people's ideas be tested in production environments and in simulation environments, because we're only going to come up with a fraction of the ideas that we need to implement on grid modernization. So that is sort of, I've had the opportunity to think of blockchain from its use cases, from the peer-to-peer, the distributed energy resources future, supply chain future, how to basically maintain a combination of trust and information exchange between parties, some of whom are new to each other. That does bring me to the concept of this playground for blockchain applications. As a blockchain application is software, but it has real effects on the grid, is that if decisions aren't executed at the right pace, then the operational functioning is not going to be there. And so it's not just about, does blockchain hash functions and create transactions, does it do it at a rate that serves the grid's purposes? And there's a lot of other dimensions that we thought about. And so that's where we created this simulation environment to help explore blockchain, working with energy sector simulations, working with hardware simulations, so that we could test our own ideas and really open up the doors for other people's ideas as well. And I think that's the most important thing to carry forward here into this conversation.
100%. And before I move down to Tony, again, you said a lot, and it was crystal to me and for our audience. Again, blockchain, depending upon the definition, folks, and we encourage whatever works for you, but one that resonates is a distributed digital record of actions agreed upon and performed by multiple parties. Don't confuse it with the whole crypto thing yet, folks, but it provides mathematical proof about the state of data, and it's commonly associated with cryptocurrencies, but cryptography and consensus mechanisms underpin this. At the end of the day, it's to build a trusted relationship, and as Chris pointed out, peer-to-peer energy transaction, boosting resiliency, and there's not just one type of blockchain. There are multiple types of blockchains that can be developed, and we're speaking about one today as it relates to the transaction of energy and the potential. So good stuff, Chris. And again, I don't ever do enough because I don't read bios, but I just got to say this. When I worked at the DOE, I was fortunate to work with Chris on what he kicked off and led and founded, which was the Green Button Data Access Initiative, which really was at the forefront of what is a smart grid way back in the day in 2008, 9, and 10. So great to see you again, Chris. Tony, you are on mute, so I don't want you to start talking beforehand. So it's just a little tip. But no, Tony Markle, I got to know Tony, folks, earlier last year when he and his colleagues, Dane Christensen and Dylan Cutler, really educated me on not just a topic we're going to speak about, a specific initiative known as Blossom, but the future, the art of the possible, and what a storyteller he is. And Tony, same question to you. Talk a little bit about this topic, why you're so excited about it, and what motivates you every day to kind of keep pushing the envelope on this very subject.
Thanks for the intro, Pete, and definitely glad to be on the panel with everyone else. Yeah, we got a really interesting opportunity here. I guess we see the electricity grid going through a pretty interesting transition. This whole sector going from, having a lot of things be controlled from a central perspective, moving out to having a lot of distributed energy resources, and end up having millions to billions of devices sitting out there on the power grid. And we're going to be in a state where we don't know what all those things are doing. They may all have different objectives. And so I think where we're headed with trying to understand blockchain and building the knowledge base around blockchain is seeing that future state and knowing that we need a way to develop, ensure trust across that entire very complex, highly distributed environment. So Yeah, the NREL team's gone through sort of a project building, stage gate building process. We started off just having two homes talk to each other through a commercial blockchain environment. Moved into being able to do transactional scenarios, understand what it would look like if you had a larger distributed network of resources doing transactions. And then all the way up, the last demo was looking at what would it look like if an entire utility grid feeder was, had homes modeled and interacting at this level. Now, what Chris and his DOE colleagues had funded us over the last couple of years to look at is, okay, now that we see some of those scenarios working out, what's the breadth of use cases that we should be looking at? And then once we know those use cases, how would we consistently go through and test and measure and understand them? And again, the whole piece here, how do we raise the awareness of what could be done with blockchain and future power grids?
Awareness struck with me, and I have to give a shout out because we will dive into Blossom, which is an acronym, folks. So I'll let Tony explain what that is, because sometimes the acronym is better stated than the actual 6 or 7 words, because it can you can get lost in translation. And just a heads up to David Benton, after we introduce or have Anthony speak, we're going to hit a little bit more on the role that David has in this incredible effort to showcase NREL as more than a renewable lab, but also one that's very focused, hyper-focused on cybersecurity and grid resilience and so forth. But that being said, Tony, you also mentioned when we chatted a year ago, the significance, and I think this dovetails with Chris as well, that systems that we have today are hard to scale, specifically EMS and ADMS. For our audience, these are the systems that manage the demand, the supply, and the reliable delivery of electricity on the grid. By no means are we saying the grid goes away, folks. Distribution is one of the 3 legs of a stool. There's generation, transmission, and distribution. Think of distribution as, in my case, it's Pepco. That's what and how I get my electricity. The idea of maybe one day homes talking to cars and homes selling and buying energy from one another, there's a lot that has to be worked out, but conceptually it makes sense. I'm down in Florida. If I were down there and I had a lot of energy on my solar panel, maybe one day my neighbor can use it and buy it from me through some digital currency and charge his car. So conceptually, hopefully that helps. So thank you, Tony. We'll get into Blossom in a minute, because I think that's the juice of really where a lot of this R&D and the specific topics going. All right, Anthony James, you are on mute. I wanted to say that it's so awesome to have you, a utility, a stakeholder, one that produces electricity. Edison, SoCal Edison, the largest subsidiary of Edison International, was a factoid that I enjoyed reading about. But Anthony, I think you're going to bring this home in many ways. You are the owner and operator of the very electricity and energy that we need each and every day. So your perspectives and passion for this topic will be very, very helpful as we go through our conversation. So welcome.
Thank you. And maybe just a little bit before we get started on blockchain, my background and how that ties into blockchain. So if I were to sum up sort of my professional journey up to this point, it would be embedded systems, software, industrial automation, infrastructure development, renewable energy, and information systems prior to joining SCE. Since being at Southern California Edison, and yes, we're seeing a lot more complexity, a lot more devices. In fact, it's kind of exploding if you really think about it. I've been involved in efforts to help the grid get ready for electric vehicles, look at not just passive strategies, standards, but more active strategies. How can we be involved more in real time to help manage the grid? Helping to improve grid flexibility as we integrate more renewables on the bulk system and on the distribution system. How can we do that more affordably, keep the costs low for ratepayers? Partnering with labs to help develop tools so we can improve grid resiliency. With the labs, for example, Stanford Linear Accelerated Lab and so many others like NREL, for example, on Blossom is a perfect example. And then looking at how can we leverage other disruptive technologies to sort of ease the pain in this journey, try to simplify a very complex environment. And so a couple of years ago, I was approached by our strategy team to take a look at Blossom to make decisions about how much should we really be involved in blockchain? Is there a benefit from it? Where's the value? And at that time, we made a decision. It was better to follow the project, the projects that are ongoing and exploration in the industry. Until recently, some years ago, Slack reached out to us and talked about this concept around Blossom. And I thought that it was important for us to be involved to help champion this effort, to explore the effort, to partner with the labs, help to guide the team and provide as much valued impact to help align the project with the needs of the utility. And like Tony said and mentioned earlier on, the number of devices are just exploding. Inverters, electric vehicles, connected buildings. Data is going to be utilized a lot more, moving from static realms to more real-time applications. And so there seems to be a very good, very strong fit, as Chris mentioned, compelling fit with blockchain, worth exploring. Data integrity and trust were the two capabilities that came to mind initially. And when we think about cyber risk and how the threat and what might happen if suddenly we have no power, how important that would be to be part of this effort to find ways in which we can improve cybersecurity within our system.
Anthony, thank you for that. And I think maybe now's the time just to kind of for everybody. Blossom stands for, let me just steal a little bit of thunder, Tony, because you'll say it a few times and we'll only refer to it as Blossom. Blockchain for Optimized Security and Energy Management. Again, blockchain for optimized security, which is why I'm going to cut over to Dave here in a minute, and energy management. So project, it's a multi-collaborative project. Shout out to the NREL, to Ames, to the National Energy Technology Lab, Pacific Northwest National Lab, the National Accelerator Laboratory, SLAC, as we know it to be, Stanford Linear Accelerator Campus. And then, I mean, it's growing all the time, but there's so many public-private partnership collaboration activities happening. I just think, again, with Chris's leadership in the Office of Electricity and folks at Nuclear Energy and Fossil Energy and Carbon Management, this is not a little project being done by a group. It's truly why our research and development community is so treasured and amazing. And if you're a taxpayer or anyone globally, you should be very thankful that these types of folks and the organizations they represent are involved. So shout out to Blossom and all the folks involved. Thank you, Anthony, for referencing that. And David, before we jump kind of back into Blossom itself and the uniqueness of it, your role at the NREL focused on cybersecurity. Cybersecurity is in the news. The Executive Order 14028 came out last year as a result of Colonial Pipeline. And people like to think, well, cyber this, do I have to pay? And nothing bad's really happened. And that's just Beltway conversations that I get to be a part of. But the reality is we turn lights on in our home and we hope they turn on, or at least we flip the switch. And we know that a threat landscape is expanding, it's evolving. Chris mentioned just in a connected world we live in. Well, if we want to have the creature comforts of, monitoring in real time, we have to ensure that that data, as this border extends beyond the walls of a building, a generation plant or a SCADA system inside somewhere in some substation. Talk a little bit, if you can, about why this focus on cyber is so important to the NREL and the role that you're going to be leading.
Sure. So we all agree that the grid is just changing. It's evolving to meet the new demands of new distributed energy, more solar, more wind, more batteries. And, we can't do that journey without knowing, how security is going to be impacted and how security is going to need to change to adopt these new technologies. So in our role at the lab, we need to look at what the grid is going to look like in 2 to 3 years and how we're going to accommodate this. And if a technology like blockchain is that glue or fabric that could help put this all together, that's absolutely where we want to go. And NREL is the place where we're able to test and simulate these things before they're actually put out into the real grid environments.
Yeah, make no mistake, folks, the national labs have this state-of-the-art, purpose-built instrumentation that if you ever have a chance to go visit, you'll be mind blown of how they can replicate the environment that is to be, and it's just amazing. So thank you, Dave, for that. Let me come back to Chris here. Chris, coming from the headquarters DOE, look, folks, you can Google Chris Irwin and you'll see more than you need to know about in the most simplest form or fashion or most complicated, intentionally, because he hangs out with the IEEE now and again, what all this means to you and why it matters. But, you know, Chris, the grid is an engineering marvel, 160,000 miles of high voltage power lines, 7,300 power plants, and the numbers may be off, you know, but these are the things when we try to articulate the complexity of the grid, and adding more devices to it to make it smarter is something I know you hold near and dear. Can you speak a little bit more about the role, the Office of Electricity, obviously your role, but why transactive energy is something folks should really start to believe is the future and the benefit to a consumer and or a business?
Well, and I think it really builds on what Dave and Anthony and Tony have been talking about, is that in order to cost effectively manage this grid, is that we don't need to purchase, own, and operate every asset that helps the grid stay reliable. Is that there are sources of cooperation with distributed energy resources, with customers, that basically allow us to use their willingness to be flexible, or their willingness to give or take energy from the grid in a way that reduces the cost of society to have an energy network out there. It's not easy. You know, we make the world more complex because we want the performance that we get. One of the analogies that I always tend to talk about is, you know, with anti-lock braking, if you were selling it at the beginning and an engineer was selling it, you're going to say it's way more complex. You won't really be in control of the situation anymore, and you will love the results. That never would have sold in the first place, but really, it's a perfect metaphor for the grid. Is we're making it more complex. We're moving control and out from that centralized source and things like that. And we're doing it because the performance could not be obtained through any other way. So we're talking about engaging with customers' assets and things like that. We need to be able to respect ownership boundaries. We can't just make their things secure. We have to respect the fact that their assets are their sovereign ownership. And so with technologies like blockchain, with technologies like transactive energy, where the grid has constraints, if it can surface these constraints in a way where you're looking for flexibility, then customers can offer their flexibility into it. And so I think when we talk about transactive energy, it's really synchronizing the grid's constraints with the customer's willingness to offer that constraint, and everybody gets paid and everybody gets a benefit. So that's sort of why we're pursuing this transactive energy future, is to limit the expense of this social energy network that we have. Blockchain, of course, figures into that, because we need the most efficient mechanism to maintain trust between parties, where we're never going to trust each other perfectly, but we can figure out a way to make a transaction happen. And so that's why it's part of the fabric of our conversation here. But I think I'll leave it back for more questions for other folks, Pete.
No, absolutely. I mean, this is not scripted, folks, if you're watching. I mean, and the segue is perfect. So Tony, let's dive into Blossom, you know, why it was built, the value it we're observing and seeing. And again, maybe mention, there's some great articles that Tony's quoted in, folks. So go to the NREL website, nrel.gov, but you talk a lot about the benefits to consumers for transactive energy. But Blossom, we need to have an infrastructure. We need to have a test bed for that. So break it down for us.
Yeah. So we saw way back, we saw that there was an opportunity when we were bringing out PV inverters, when the industry was really going down that path, that there needed to be a way for everyone to kind of characterize performance of those in a common way. Did kind of work through the whole IEEE process to find here's what's the ins and outs and all that kind of stuff. Roll up to where we are right now. That was kind of the conceptualization of our Blossom project was, look, let's build the wrappers around blockchain and have pieces that drive that wrapper through various scenarios so that we could then look and understand kind of under the hood what's blockchain doing for us in this case and what's it doing for us in this other case. Well, we basically mapped out at the very beginning of the project, we theorized, hey, there's like 14, 15 different scenarios of ways that we might choose to use blockchain in power grid scenarios. We didn't have the resources to do all of them. We down selected, came down to a couple of them that we thought were kind of highest near-term priorities, ones that we could build. We already had models available for kind of driving the input side. Those two cases right now that we developed in the project, one's focused on supply chain security. So how do we keep track of what each vendor sort of put into their device, who's owning those, when do updates happen on those systems? Are there any cybersecurity vulnerabilities that are associated with individual devices that are already out in the field? So this is kind of like it's an add-on to asset tracking, advanced asset tracking, a little bit more active in that it can have some responsiveness built into smart contracts that basically go through an automated alert kind of function. If there's a vulnerability known, now we can alert the appropriate parties and action can be taken. So that was one of the use cases that we developed up. We've got all the kind of plumbing on the front end to kind of put those transactions in, put components from the grid into an architecture, and then the system kind of sits in the background listening, and blockchain will help us kind of make those connections between the necessary parties. And part of that piece is that not every vendor needs to know what's going on with every other vendor. And so utilities that have vendor A in, and utilities that have vendor B in there, they have access to the various channels, and the rest of the architecture can be separated. So interesting kind of scenario that we've pushed it through there. The other one is more focused on the transactions that you're talking about. So we built up the driving functions for if we had a collection of distributed energy resource aggregators, people that basically contract for individual homeowners to interact with the utility. And so on that side, it's taking the assets, giving them information about what the current state of the grid is, letting them decide on a bid scenario, pushing those bids up into a market transaction. And now you've got transparency, everybody understands what everyone else is doing. And now you can have individual stakeholders making decisions based on their own interests, but also understanding it at a grid level, and the utility then being able to understand what do they have to do to maximize the value of all those distributed energy resources in the system. So anyway, big picture is, Blossom is there as a interaction engine to drive blockchain outcomes, and then wrap around that understanding what the performance of the whole system looks like. We have some really interesting questions left to look at cybersecurity. We have interesting questions and to understand, architecturally, how should the blockchain environment be built to be efficient? What's the overall energy costs and overall kind of value stream that comes from implementing these pieces? So, we had 2 years to work on this so far. We've put together a lot of the good foundational pieces. Still plenty of questions to be answered still with additional effort.
Yeah, I'm Tony, Anthony. I'm going to come to you because obviously you're your perspective on something like the Blossom, which is multi collaborative, right? And there are utilities that might say not in my backyard, or some that might, and I'm not implying you're on either side of that, but your perspective will be key. I just want to say one thing to everyone, what Tony hit on, that again, there's not one blockchain. There could be blockchains for specific use cases, supply chain security, appliances talking to one another. And I go back to something Chris mentioned early on, this connected world that we're moving into, having peer-to-peer energy transactions someday. It's not that it's, hey, why are we trying to change? It's because the grid and the pricing models we have today, look, you can read about this stuff. When you want the creature comforts of a turning your thermostat on when you're down at the beach and you forgot to reduce it while you were away, and you could do that from your phone, you also have to understand the risk.
Mhm.
And putting in the cybersecurity and physical security mitigation to a blockchain for transactive energy is all part of it as well. So if you dive into this, folks, there's a lot going on behind the scenes when you flip that switch on in the future or use your app to turn on your generator. So Anthony,
Yeah.
talk to us from a utility that I'm sure has reservation, but also likes to be forward leaning. What is the Blossom project? And do you have similar types of efforts underway that you could share? I was reading about, if I'm not mistaken, CES 21 is a project that caught my attention at SoCal Edison about industrial control system security and grid modernization. But how do you and your brethren feel about something like a Blossom project being invested in?
So I just wanted to echo one of the things you talked about. So you're correct. So there's lots of blockchains. So blockchain is the original Hyperledger. There are now lots of Hyperledger technologies building upon and working its way through opportunities and weaknesses with the original blockchain. And so it's important to sort of demystify that and also separate that from cryptocurrencies. This project is more focused on blockchain or Hyperledger architecture and what that can do for the utility industry. Again, as I mentioned earlier, I think it's important for us to champion these projects. It's important for us to help guide the teams, provide as much input to the project, make sure that the work is as relevant as possible. It's aligned. There's as much real world experience into the project as far as, what are the challenges today? And how might we move from a research project into production? That's often a big challenge, but from our perspective, it's always one of the questions that we get asked is, how are you going to use this technology? How are we going to move from the lab to our lab, validate it, test it, and then deploy it? How is it going to create value? So oftentimes, that is the challenge with many of the R&D efforts that we're involved in. We're involved with R&D efforts with Pacific Northwest National Labs in trying to figure out how we can better get the grid ready for electric vehicles, to anticipate the electric vehicle load on the grid, and what's the best way to respond? What's the least cost, least regret decision that we can make to continue to invest in the grid, to keep customers happy, and to enable electric vehicles to be integrated to the grid. We're also working with Stanford Linear Accelerator Lab, also in grid resilience, looking at how we can minimize the impact of climate change, for example, to our assets. We can simulate extreme weather events, what that might do to assets. How will the grid respond? Will we have enough capacity? Will the grid break? Will customers be affected? This is very bleeding edge, cutting edge work, and oftentimes very much separated from the normal day-to-day operation of the utility. So in addition to the technology and the development being quite a bit more forward thinking than the day-to-day work of someone at the utility, there's always that bridge in terms of not just advancing the technology, but the communication about the work that's being done and trying to package it in such a way so utility folks can understand the value and how much more they might need to be involved to help bring these technologies forward.
Yeah, Anthony, I'm going to ask you a quick question just because it's one
Yeah.
I have to sometimes offer my opinion on, but I've never
Sure.
worked in a utility. I mean, the demystify word I loved,
Okay.
myth or truth. And people hear things like, oh, you're going to put a sensor on this, it's going to allow a bad actor to come in.
Right.
And, is that something that you have to take on that role about demystifying the truth and the reality versus, hey, we can't throw the baby out with the bathwater here. I mean, we need to embrace innovation, correct?
Correct. There are a lot of challenges with innovation in the utility industry. As you know, our utility is a public company. But there is that challenge. And yes, we do have to figure out ways to best package the work, so people can understand the value of the work. And so it is a challenge. Oftentimes you might hear folks respond, "Oh, that sounds like a cool project," right? But it's not just cool. There's a lot of value with that work. It's very difficult. It's very challenging work. When you think about startups and how often startups fail, and sort of the immense pressure on R&D efforts to actually create value from the ground up, it's a very difficult task.
Yeah. So let me take that for a minute and maybe just pivot over to David. David, he
Sure.
mentioned startups. So I kind of wanted to go to let's see if I get this right, the Clean Energy Cybersecurity Accelerator. Maybe just because it was a really cool announcement last year, can you just reference that a little bit about how you, in your role, are encouraging this collaboration with utilities and entrepreneurs to kind of drive this next generation energy grid?
Sure. So, and thanks, Pete. So the accelerator program is just getting started. We're getting ready to announce cohort 1 in the April timeframe. There's 3 utilities involved. Right now it's Duke, Xcel, and Berkshire Hathaway. So those 3 utilities are basically pooling their money to do R&D research on the evolution of the grid, kind of everything we're talking about today. Now, will blockchain be the first cohort? Probably not, but it's definitely going to be somewhere along the way. I could totally envision doing some cohort with blockchain technology to prove its security, prove its value, prove that it works the way we're expecting it to help the grid.
Yeah, great point, and shout out. And let's be clear, it kind of already started because Blossom exists, and maybe you jump on that train when you're ready to. But I know that's a great program, and really excited to see how that grows and matures, if you will, as a program. Chris, I got to ask, kind of similarly, and guys, literally guys, if you have a question, cut me off. But I mean, I'm just making sure we all got some equal airtime here. But, we've got a utility perspective, Chris. We've got research and development in Tony, and we got programs that Dave's leading and all the great people. And you, more than anyone, understand that takes a village. And you're somebody in the Office of Electricity in the United States Department of Energy. And there's a different dialogue in this beltway we live in about expressing the value of making really heavy investments. You mentioned, would you say, with a B in it, $1.6 billion of programs. How have you seen your mission and the industry, in the last 10 years just truly evolve in front of us? And could you have predicted where we are today 10 years ago?
I'm sure I did predict it.
Well, you're Nostradamus in today's day and age. I mean, come on.
I think that the thing that really has evolved is the number of parties involved in addressing society's problems as it relates to energy. Is that a siloed existence in the energy sector was the preferred existence. Is that the distribution utility really didn't need to rely too terribly much on customers too much. And the transmission system really didn't need to rely on information coming from the distribution system. It was a one-way flow. It could be managed in silos. Now, as almost every one of those silos is breaking down, is that transmission cannot optimize without distribution, and transmission cannot understand its control requirements without information exchange across the distribution interface. A distribution utility can't operate at optimum efficiency without some method of coordinating with customers and things like that. We could retreat to a siloed existence. It would simply be an expensive existence. And so I think that's probably the biggest evolution in the grid. Problems are moving into a bigger family environment where we have to work with others, and we're going across ownership boundaries and trust boundaries. And at the end of the day is that people have figured out how to work with people most days, but our machines have not. And so that's sort of one of our obligations in the research space.
Yeah, Chris, that's a great point. And I'm going to jump down here to Tony and then Anthony. Well, I mentioned the executive order 14028 came out. And if anybody reads page 1, the executive summary kind of stuff, it's pretty self-explanatory. The worlds are converging. A utility, also known as operational technology that they live in, SCADA systems, programmable logic controllers, I mean, mouthful, but if you Google OT and IT and the word integration, to Chris's point, a threat landscape, more devices require us to kind of converge. And OT and IT, information technology, think internet, the stuff that we have today that people like to say, well, that causes bad actors to cause something bad to happen. Hey, if we want to build a more resilient, flexible, sustainable grid, the OT and the IT integration, leveraging cloud, or maybe looking at advanced analytics or zero trust architectures, this is the stuff 10, 8, 9 years ago weren't even thought of, but now you have to think about. And it's a crowded space. So with that, you know, Chris, off of what you were saying, Tony Markle, you know, the project aside, can you speak to how that breaking down of barriers has happened? Has it morphed? Is it getting to the point where more people want in, and it's not so much the intrigue of blockchain, but I think, you know, from an entrepreneurial standpoint or a scientific standpoint, people are getting really excited about this future state of transactive energy.
It's a great question. It's hard to, I guess I'd say it's hard to gauge. I feel like there definitely is an excitement about adopting renewable energy technologies. You know, there definitely seems to be a growing interest there, a growing value proposition for the utilities. And so I think, you know, the general trend is going that way. All of these things take a lot of time. You know, we have the grid is the largest machine in the whole world, right? And so it's going to take time for this transition to happen. And so that's where the research labs kind of come into play, is we have an opportunity to theorize what things are going to look like, try to put the right pieces together in the lab, and answer some of the questions along the way that people have. So yeah, I think my core message there was, you know, what we do at the labs and what we rely on Anthony to give us input on is, you know, how do we understand and build trust within the technologies that are coming to fruition? And so yeah, that's our job. And I think Anthony, I really appreciate what Anthony's kind of guided us towards in some of the projects. You know, we're engineers, we like to plug things together and make it work. Sometimes it's with, you know, tape and rubber bands, but he brings this reality to us and says, look, if any of this is going to come into play, we got to make sure that it's got all the right cybersecurity implementations in there. We understand what the risks are of putting distributed ledgers in various locations. How do we protect those pieces, right? So I think those kinds of combined thought process of researchers in a lab environment, industry partners who bring reality of, you know, security and value that has to come from those projects has been great. And that's why DOE drives us to have industry partners integrated in all of our projects wherever we can.
Great point. And we'll be heading into parting shots here. I mean, we can talk for hours on this. I have one question for Anthony, though, before we go there, because having lived the life of a chief technology officer, where one of my functions was to invite anybody and anyone who thought they had a great solution to a problem and wanted to pitch me and my team, I said, come on in, just make sure you did your homework and you know what my mission is. How do you, Anthony, or do you have a sense of the utility sector doing technology due diligence, right? A lot of these IT companies today, I can name 10, but I don't want to have somebody calling me and saying, why didn't you mention my company? That claim to protect data effectively. And if you allow us to look and examine, we can utilize artificial intelligence to make prescriptive and predictive decisions. How do you and or your SoCal Edison community conduct that in a proactive manner versus waiting for a compliance or standard to come down the pike?
There are a lot of technology vendors that come to us with solutions. Some solutions solving specific problems we care about, some solutions that are, looking for a problem to solve. We have processes, sort of gates, so to speak, to help bring technologies in and have subject matter experts weigh in on not just whether or not a problem is going to solve the solution, but if it's the right business model for us and also for the technology company, because they have to make money, they have to sustain their business, they have to be around if we're going to partner with them and integrate them into our grid. So typically we have at our advanced labs, we every 3 or 4 years we conduct pilots and demonstrations, mostly funded by the California Energy Commission, where we bring technologies in that we believe are promising. And this is after doing some due diligence, not just looking at the technology worthiness, so to speak, but also looking at is there going to be any value to the grid, to us? Maybe a little bit more about the company. Is the company going to be around? If we invest our time, we have to know that in 2 or 3 years, if we plan to deploy the technology, they have to be around to maintain it, for example. So typically our process is we validate the technology in the lab, we test the technology. So not just verifying that the technology solves the problem, but validating that the technology solves the problem well enough to meet our needs. And then at that point, we go through a technology transfer to commercialization process where we integrate the technology and we look at technology maturity, not just from the perspective of is it commercial ready, but also is it a technology that is ready for people to use? Because there's no point in deploying technology if it just sits there and nobody uses it, or it's just too hard to use. Or one of the big challenges today is, can we even integrate it in current systems? So we're looking at, how can we take our traditional assets and integrate them with next gen assets? How can we leverage the best of what we already have and integrate the best of what's coming down the pipeline?
Word stuck with me, integration, and thank you for at least, again, helping me feel good about, you don't just knock on the door of the government or a utility and say, I've got the silver bullet to solve all your problems.
Sure.
Integration's involved. And again, I encourage folks to just read page 1 and 2 of the executive order, which again was really in response to what happened in Colonial, which was a lot of things on the heels of what happened in Texas. So awesome, awesome stuff. Well, listen, I hate to say this is the part where we go to the parting shot, only because I want to keep talking and learning myself. But what I'm going to ask of our esteemed guests, and we'll finish it out with Dave and some really cool information about how to engage with the NREL, is leave something. I'll start with Chris and I'll wax for about 10 seconds so you can get your thoughts, since you're the Stuckey to be the kickoff to parting shot. But what did you hear today? What do you feel is a message that folks need to know, whether they're blockchain experts or interested in crypto? What do you want to leave with the audience based on today's topic, Chris?
So it goes back to your trite but highly accurate phrase, as it takes a village, is that, just like I said previously, is that the Office of Electricity is partnering with the Energy Efficiency and Renewable Energy, with the Fossil Energy Office, the Nuclear Energy Office. So we are collaborating to find the best solutions, and the national labs are gathering together to deliver the best solutions to that. But I think in the parting shots is that blockchain has a lot of potential use cases in the energy sector. We've worked hard, mostly Tony has worked hard, I have said work hard, to construct a testing ground, a playground for blockchain applications. We have exercised 2 of 16 use cases that we thought of, and we know that the private sector can think of more. And so really, I'd like to throw the doors open for people to bring their ideas to us, so that we can be successful in our mission to our national infrastructure.
Amen to that. Collaboration 101. And if you didn't hear that, folks, 2 of 16 use cases. If you have an idea, bring it forth. Thank you, Chris. Tony Markle, the floor is yours for your parting shots.
So I think where we've gotten to is a really fun place because we have things that work. We put it together. This is kind of version 1 though. And so I think the thing that excites me about going forward is in working in a lab environment is I think it's a good chance to break things. Break it now before it goes out into the field, so that then we can give the industry partners, version number 3 or version number 4 that we feel like is actually strong, reliable, resilient to cyber attack. So that's what I think I've taken away from the project. Is it's been a good place to start, but we got lots more that we are excited about working on.
Good luck moving forward. Obviously, I'll be tracking, and I think Blossom is indicative of just an amazing opportunity to get involved and to, as I like to say, move that needle towards a more resilient grid that benefits humanity. So thank you. Anthony James, parting shots.
Sure. So what comes to mind is, so yesterday I had a call with one of our cybersecurity experts who had the opportunity to participate on the blockchain presentation. And one thing he said was, "This is very exciting," and so that was great to hear. We expect to have some follow-up internal meetings with cybersecurity, but what I'm hoping to see as sort of a next step is, where are we in terms of bridging that gap? Not having for this effort to sort of fall into the valley of death. And we're all the bridges. And one other thing I'd like to say, and this is sort of utilities. So we're in some people say we're in the most disrupted industry today, the utility industry. Very highly regulated, complexity is increasing. We need the national labs. It's very important for utilities to participate and put more skin in the game, be involved to help guide these teams. Because a lot's changing really fast, and we need to be able to maintain those connections with the folks in the labs who are working to kind of help solve the problems we care about.
Yeah, if the theme isn't been understood, or hopefully it has, that participatory, transparent, and collaborative purpose of government to engage with industry is really what open government's about, and well said. And just a quick shout out, folks, the Federal Energy Regulatory Commission, the North American Electricity Reliability Corporation, I hope I got that right, but NERC, FERC, and NIST are also very involved in these discussions, and we would have loved to have that representation, but we would have absolutely needed more time. But thank you for that theme. And before I kick it to Dave, my parting shot is, look, this is, as Anthony just said, it's building bridges, relationship bridges, connecting dots, on technology, on why this matters, okay? I think if nothing else, try to take a sample of this. Don't try to learn blockchain, but read about Blossom, and you'll probably innately understand the value of blockchain and digital currency, and why the grid is a great use case to understand it versus being caught up in like Bitcoin and Ethereum. Nothing wrong with that, but that's just a piece of it. So thank you for being here today. David, over to you to close us out with a parting shot or two and some more information on the wonderful lab.
Great, thanks, Pete. Yeah, I think we really hit the mark on this one. I think when we think about where we came from and how this idea came to fruition, I think everyone's going to walk away with a lot more information they had before on blockchain and energy than they did before the session. So nice job, everybody. So with that, I wanted to thank all of our panelists. So Chris Irwin from DOE, Tony Markle from NREL, Anthony James from Southern Cal Edison, our administrators, Emily and Nika, thanks for your help. And last but not least, Pete, thanks for being a great moderator as always. Great. So thanks again for everybody who tuned into this. And if you'd like more information about any of the research we do at NREL, we've got the URL there at nrel.gov. You can always email me, david.benton@nrel.gov, for information or how to connect with us on any of the security programs at the lab. So with that, thank you again for joining, and hope everyone has a great day.